Okay guys, we're doing 1.1 Algebra Review. Okay, first thing, let's talk about some of the formulas from algebra that you might be using in calculus. Okay, first thing, the slope, y2 minus y1 over x2 minus x1. Remember, you're going to need 2 points. This is your second point, this is your first point, and you plug them in, okay, your x and y coordinates. After you have the slope, you're going to use this equation, point slope form, in order to calculate the slope. Remember, you're going to need to solve for y, so it goes into the y equals mx plus b form, okay? And I know you guys remember that from Algebra 1. It's engraved into your head. It's beaten in there about 5 billion times. Okay, so you're going to need to solve for y after you use this. Okay, some common values you're going to need to use. These are things that you should remember from Algebra 2 or pre-cal if you didn't learn it. Natural log of 1 is equal to 0. Let's draw a little graph of that. Natural log starts close to the y-axis. It goes up, crosses the x-axis at 1, and then it just continues to increase, okay? That's your x equals 1, and it has a y value of 0, meaning this. Draw this graph down on your piece of paper. Remember, that is y equals natural log of x, okay? Oops, natural log of x. That is an ugly natural log, but it's all right. Okay, next thing is e to the 0 equals 1. The graph of that one, okay, y equals e to the x. You need to also know, just understand what the graph looks like. They are inverses of each other, meaning that they are reflected across the line y equals x, so it's going to look very similar. It's going to start near the x-axis and go up and just increase. Okay, the reflections of each other across the line y equals x, and this one at x equals 0, your y value is 1. Okay, and these two things you need to have memorized. So write them down. Do everything you can to remember them. Okay, exponent rules. Let's go up here to this. Okay, remember, multiplication means addition of exponents. Division means subtraction of exponents, and a power to a power means multiplication of exponents. These three rules you have to have memorized. I'm sure you use them several times in algebra. Also, remember, anything inside of a parentheses being raised to an exponent, that means that every single thing in there, A and B, are both being raised to that exponent. Same thing here with division. Everything in there is being raised to that exponent. Here are some rules maybe you don't remember very well. If it's a negative exponent, you can flip it onto the other side of the fraction, and it becomes a positive exponent. Here's another example: 1 over a to the negative n. Let's say we're talking about a negative being on the bottom of the fraction. That can be rewritten as just a to the n. Yeah, so if you just flip it from the bottom, if it has a negative exponent, you flip it from the bottom to the top, it becomes positive. Same thing if it's a negative on top, you flip it to the bottom, it becomes positive. Okay, you need to make sure to rewrite all expressions with positive exponents. This right here, a to the negative n, is not a simplified expression. Negative exponents are bad. Okay, next thing you might have forgotten is square roots are the same thing as fractions exponents. So square root of a is the same thing as a to the half. Another way of writing that, like let's say we do cube root of a. Okay, another way of writing that term would be a to the 1/3. Okay, a to the 1/3. Let's do another one kind of similar. Maybe if what would a to the 2/3 look like? At a to the 2 over 3. Okay, that would be the same as a cube root. Okay, that's a 3 cube root of a squared. Those two things would be the exact same. Okay, that's everything from this slide. Let's go on over to the next slide and do our first practice problem. Okay, looking at this will be our first practice problem. It's simplifying the rational expression, and in order to do that, you're going to need to look at the numerator and denominator. and you're going to see what you can factor out of each one of these. If you notice this on top, a 3 and an x can both be factored out of both of those terms. If you do that, what you would need to multiply this by to make it 3x squared, if you took a 3x out, would just be x. Multiply these two things, it equals the same thing there. Okay, if you took the 3x out of here, what would you have left? Looks like you would have a 2. If you multiplied 3x times negative 2, you're going to get negative 6x. So if you distribute this 3x to both of those, you have the exact same expression on the numerator. Okay, this denominator here. We have, if you remember this, it's factoring binomially. You got two factors here. The first expression on here will be, when you multiply them, it'll be what you have to get x squared. That dot was an accident. So x squared here. Okay, to get to the terms on the end here, it's going to be whatever this is. So it's going to be multiples of this. So 6 times 1 could be a multiple, 2 times 3. And you have to figure out which one of these it's going to be. If you notice here, you need to be able to add or subtract these numbers in order to make this number here. And if you notice, it's 1x, positive 1x. I can't add 6 and 1 or subtract 6 and 1 to make 1. It's either going to be 7 or it's going to be 5 if I subtract them. This one, if I add them, it's 5. If I subtract them, though, I can do 3 minus 2. And so I'll have a 3 over here, 2 right here. And my 3 is going to be positive, and my 2 is going to be negative, and 3 minus 2 would be that 1x right there. So we got our solution here. If you FOIL this out, you distribute everything, it's going to equal this right here if you want to check yourself. Okay, if you notice on the top, that cancels out with that, leaving us with our answer, our most simplified expression, 3x over x plus 3. And that would be our solution, the most simplified rational expression. Okay, let's go over to the last slide here. Okay, let me get my pen. Okay. On these, what we're going to be doing is trying to solve for x. So on this side, we need to isolate x. That means we need to get rid of the e. Remember, you got to know what the inverse of e is in order to solve for x. If you remember what I was just telling you guys, the inverse of e is natural log. So the natural log of this whole thing, it'll cancel out that e, leaving us with just this expression here. Remember, whatever you do to one side, you got to do to the other. So I'm going to have natural log of 1 on this side. And this you should know. I just told you guys what natural log of 1 was, and told you to memorize it. And that is a 0. And remember your graph. The graph of natural log looks something similar to this. I know I'm bad drawing, and it crosses right there. But that's the natural log of x. So natural log of 1 is 0. And then over here on this other side, the natural log and e, they cancel each other out. They're inverses of each other. And this becomes your only term on the left-hand side. It's no longer an exponent. It's 3x squared minus 5. That's all we got over here. If you want to know more, it's difficult to explain stuff on here because I can't really draw. But just ask me and I can explain it a lot better. Okay, now we're just going to solve for x. So this should be the easy part. We're going to add 5 to each side. So we're going to have 3x squared equals 5. Okay, next thing is we need to get rid of this 3. So I'm going to divide by 3. I'm going to have x squared equals 5 over 3. That is a 5 over 3. And then the last thing, to get rid of that square, you just need a square root, right? That's going to be the inverse of that. So our answer is going to be the square root of 5 over 3. And if you write that as your answer, I'm totally going to count it wrong. And here's why. Remember, when you square root, it leaves you with a positive answer and a negative answer. You have 2 answers here. X could be a positive square root of 5 over 3 or a negative square root of 5 over 3. Okay, that would be your solution. Let's go over here to this last one. We need to isolate x over here, meaning we need to get rid of the natural log. But first, we need to get rid of this division by 4 and that addition of 20. So let's just multiply by 4. Remember what you do to one side, you do to the other. So multiplying by 4. And then that'll cancel it on this side, leaving us with natural log of x plus 20. Equals 20. Sorry, that dot was an accident. Okay, equals 20. Okay, now what we're going to do is we're going to subtract 20 from both sides. So subtract 20, and 20 minus 20 obviously is going to cancel it from this side, and it'll leave us with 0 on that side. So natural log of x equals 0. At this point, you should know what natural log of what is 0. I mean, we just did that over here. But so the answer is going to be 1. But let's do the inverse of this so you can see how to do it. The inverse of natural log we said was e. E is being raised to stuff, so we need to write e raised to the natural log of x. Remember, what you do to one side, you do to the other. So e to the 0. Okay, this cancels it out, and for the same reason, which if you want to know, come and ask me, this exponent now becomes our base, and it's x equals, and e to the 0, remember I just told you guys what e to the 0 is. It's 1. Remember that graph of e to the x. The graph looks something similar to that right there, and it crosses right there at 1. That little line was an accident. Okay, and that looks like everything. Good luck on the worksheet. Remember, the solutions are online. Some hints to help you out, the answers to check your stuff.